Now, another question asked in JEE Main Shift 2, Evening Shift, September 2. Young modulus of a string of length 1 meter and density 900 kg per meter cube is 9 into 10 to the power of 9 Newton per meter square. Find the minimum resonance frequency in H can produce in the string of a strain in the string is 4.9 into 10 to the power of minus 4. So, what is the minimum frequency here? F is equal to 1 by 2L square root of T by nu. T by mu. So, this can be written as 1 by 2L square root of T by A into A by nu. T by A into A by nu. There is no change in value. Right. Here, Young modulus is equal to what? T by A. That means tension means force by A by strain, longitudinal strain, that is treated as epsilon. Okay. So, here T by A is equal to Y into epsilon. Epsilon means what? Strain. Okay. Right. Here mu by A. Mu means what? Mass per unit length. Mass per unit length by A. L into A. Length of the wire into area of cross section volume. Mass by volume. That is equal to density. Here A by nu means what? 1 by rho. 1 by rho. So, F is equal to, we write here 1 by 2L into T by A means what? Y into epsilon. A by nu means what? 1 by rho. Now, 1 by 2 into, what is the length of the wire here? Length of the wire is 1 meter. 1. What is the Young modulus of the wire? And Young modulus of the string is 9 10 to the power of 9. 9 into 10 to the power of 9. 9 10 to the power of 9. Strain, what is the strain given in the string? 4.9 10 to the power of minus 4. So, here 4.9 10 to the power of minus 4 divided by, what is the density they given? Density they given is 900 kg per meter cube. 900. 900. So, by solving, now let us solve this equation. Right. Here 1 by 2. This 9 goes into 100 times, cancel 100 times. Now, here 4.9 into 10 power 5 divided by 100. F is equal to 1 by 2. Okay. This is right as 49 10 to the power of 4 divided by 100. 1 by 2 square root of 49 is equal to 7 10 to the power of 4, that is equal to 10 square by 100. So, that is equal to 700 by 200. 700 by, what we get here? 700 by 200. Right. 10 to the power 10 square here. Here we write a square root of 100 is equal to only 10. That is equal to 10 into 2, 20. So, here 0 0 cancel. So, F is equal to how much? 35H. 35H. Here we write square root of 100 is equal to 10 only. So, mistakenly write 100. So, by correcting we get this is 10. 700 divided by 20. 0, 0 cancel. 35H. Okay, now let us discuss another question. A particle is projected with a velocity v at an angle 60 degrees with field. It makes 10 revolutions before coming out. Find L, total length traveled by the particle. So this question is asked in shift 1 also. This is a particle, charged particle, which is projected into the magnetic field at an angle 60 degrees with field. Then it is influenced by the two velocities. This is v sin theta and this is v cos theta. As a result, it moves in a helical path. Now, what is the time taken to complete one revolution? The time taken to complete one revolution is equal to T is equal to 2 pi m by qb. 2 pi m by qb. Now, distance traveled by particle after 10 revolutions. 10 revolutions. That is equal to v cos theta into t into 10. T is nothing but what? Time taken to travel to complete one revolution. So here v means v cos 60 into 2 pi into m by qb into 10. So here v into cos 60 1 by 2 into pi m into 10 by qb. Right here 2 gets cancelled. 2 gets cancelled. What we get here? 10 pi mv by qb. This is the value of L. Value of L. Right. Efficiency of a cyclic process is 50%. If heat Q1 is equal to 1915, Q2 is equal to minus 40 joules and Q3 is equal to 125 joules, then Q4 is unknown, then find the value of Q4. Find the value of Q4. So we know that efficiency is equal to total work done by heat added. So total work done is equal to Q1 plus Q2 plus Q3 plus Q4 divided by heat added. Here there is a negative sign is also given. Positive sign means heat is given to the system. Here positive sign heat is 1915 joules, Q3 125 joules. So heat given to the system is equal to how much? 1915 plus 125. Okay, Q1 plus Q2 plus Q3 plus Q4, that is equal to here 1915 plus Q2 minus 40 plus 125 plus Q4 divided by 2040. Here efficiency is 50%. That is equal to 50 by 100. Neta is equal to 1 by 2. 1 by 2. So 1 by 2 is equal to here 2040 minus 40, 2000 plus Q4 divided by 2040, right. So 1 by 2 into 2040 is equal to 2000 plus Q4, that is equal here, this is 1020, this is here 1020 is equal to 2000 plus Q4. So Q4 is equal to 1020 minus 2000, that is equal to minus 980 joules. Minus 980 joules. The value of Q4 is equal to how much? Minus 980 joules. Now let us solve another problem. A square of side A by 2 is removed from disc having radius A. Find the center of mass of remaining portion. So this is a disc, and this disc has a radius A. From this disc a square is removed whose radius is nothing but how much? A by 2. Then what happens? Center of mass is shifted towards left, this side. Okay. Find the center of mass of remaining portion. Here there is a direct formula given. Distance of center of mass of remaining portion is equal to A1 x1, area of the original disc, into distance of that original disc, distance of center of mass of original disc, minus removed part area A2 into distance of center of mass of the removed part from the original disc x2 divided by A1 minus A2. A1 minus A2. This is the formula to solve this problem. Here this is a circular disc. This is a circular disc. Where the center of mass of the circular disc is located? At this point. What are the coordinates of this center of mass? 0, 0. 0, 0. Right. Here we write area of this disc pi r square into center of mass is located at 0, 0 minus A2. A2 means area of the square. Area of the square is equal to how much? A square by 4. A square by 4 into, so distance of this center of mass from this point is equal to how much here? A by 2. A by 2. That is equal to how much? A by 2. Right. Divided by area of the disc, that is equal to how much? Here pi, what is the radius here? Radius of the disc here A, pi A square. This is also A square minus A2, area of the square. Area of the square, that is equal to A square by 4. Right. XCM is equal to, this is 0 minus this is A cube by 8 divided by, take LCM 4 pi A square minus A square. So XCM is equal to minus A cube by 8 4 pi A square minus A square. that is equal to here 4 1s are 4 2s. Okay. So what we get here, final answer, we get here final answer minus a cube by a square into 8 pi minus 8 pi minus 2. 8 pi minus 2. So this is cancelling 8 times. This is cancelling 8 times. So here we got minus a by 8 pi minus 2 minus a by 8 pi minus 2. 8 pi minus 2. So this is the final answer. The center of mass is shifted towards the left of this. That's why here negative sign occurs. Now another question. A capacitor of capacity 20 microfarads is charged up to 50 volts and disconnected from the cell. Now this charged capacitor is connected to another capacitor, another uncharged capacitor of capacitance C. If a final common potential is 20 volts, then find the capacitance C. This model is asked in shift 1 also. Whenever this is a capacitor, this is fully charged up to 50 volts, and this capacitor is connected to another uncharged capacitor whose capacity is C. Then what happens? Here they share charges equally. So finally they attain a common potential. That common potential V is equal to C1 V1 plus C2 V2 divided by total capacity C1 plus C2. C1 plus C2. C1 V1 plus C2 V2 divided by C1 plus C2. Okay, that means charge is conserved, total charge is conserved. Initial total charge is equal to final total charge. From that principle, we obtain here expression for common potential. Initial charge on the capacitor Q1 plus Q2, charge on the capacitors, that is equal to final charge Q1 dash plus Q2 dash. Q1 C1 V1 plus C2 V2 is equal to what we get here, Q1 dash C1 V plus C2 V. That means they attain common potential. V equal to how much? C1 V1 plus C2 V2 divided by C1 plus C2. Now substitute these values. Here what they given, C1 is equal to 20 microfarads, C2 is equal to C, V1 is equal to 50 volts. So V2 is equal to how much they given? Uncharged capacitor, that is equal to 0 volts. 0 volts, that is uncharged capacity. So here V is equal C1 V1 20 into 50 plus C into 0 divided by C1 plus C2. C1 plus C2 means 20 plus C. 20 plus C. Here the common potential they given 20. So 20 is equal to 20 into 50, 1000 by 20 plus C. Cancel. 2 into 2, 40. Okay. So here 2 into 2 is equal to how much? 40 plus 2c is equal to 100. 2c is equal to 100 minus 40, that is equal to 60. C is equal to 60 by 2, that is equal to 30 microfarad. This is the correct option, 30 microfarads. Let us solve another problem. Here, this problem is based on the quotient of thermal conductivity. So, read this problem. 1.56 into 10 to the power of 5 joules of heat is conducted through a 2 meter square wall of 12 centimeter thick in 1 hour. Temperature difference between the two sides of the wall is 20 degrees centigrade. Find the thermal conductivity of the wall. So, what they given here, how much amount of heat is supplied? Q is equal to 1.56 into 10 to the power of 5 joules. Conducted through a 2 meter square wall of 12 centimeters thickness. So, area of wall 2 meter square and thickness is equal to, that means D is equal to how much? 12 centimeters. 12 centimeters. Right. 12 centimeters. That is equal to 12 into 10 to the power of minus 2 meter. In 1 hour time. So, time is equal to 1 hour, that is equal to 60 into 60 seconds. So, we know that K is equal to formula QD by A into theta 2 minus theta 1 to T. Theta 2 minus theta 1 to T. Q is equal to how much here? 1.56 into 10 to the power of 5. D. Thickness 12 into 10 to the power of minus 2. To the power of minus 2. Divided by here area 2 meter square. Temperature difference how much? 20 degrees centigrade. T 60 into 60. Here theta 2 minus theta 1 is equal to 20 degrees centigrade. Now K is equal to here 1.56 into 12. By solving multiplication with 1.56 into 12, we get 18.72 into 10 cube divided by here 2 into 20, that is equal to 6 into 6, 36, 36 into 2, 72, 72 into 2, 144. Here 10, 10, 10, that is equal to 10 cube. 10 cube. Now, by solving this, here 10 to the power of 10 to the power cancel, 18.72 divided by 144, that is equal to, by solving we get answer 0.13. 0.13. So, our option is, correct option is 0.13. This is the correct option. So, let us solve another question. An object weighs m1 in a liquid of density d1 and that in a liquid of density d2 is m2. The density of the object is, density of the object is. So here this is a liquid of density d1. So this is a object whose real weight is m0. Let us assume as m0. That means actual mass. Actual mass of object is equal to m0. V is the volume of object. Volume of object. Whenever this object is placed in a liquid of density d1, then there is a buoyancy force is acting on this object in upward direction. That buoyancy force is nothing but Fb. Then weight of body, weight of a body in a liquid, that is equal to, here what is the m1, that means m1 into g is equal to real weight minus buoyancy force. Real weight minus buoyancy force. Real weight is equal to how much? m1 naught, m0 into g downward minus buoyancy force. So here m1g is equal to m0g minus buoyancy force. So buoyancy force means here V is volume of the object immersed in a liquid, D density of the liquid T1g, right. So here G is common, m1 is equal to m0 minus V into d1. This is equation 1. If the same body is placed in a liquid of density d2, then what happens? Its weight is m2g downward direction. Weight of the body. Weight of the body in a liquid is m2g. So weight of a body in a liquid of density d2, that is equal to how much? m2g is equal to real weight m1g minus buoyancy force. Buoyancy force means here V is the volume of the object and D2G. D2 means density of the liquid. Right. Here take G common. M2 is equal to m0 minus Vd2. Equation 2. Equation 2. Now subtract equation 1 from equation 2. 1 minus 2. Here what we get here? m1 minus m2 is equal to Vd2 minus VD1. VD2 minus VD1. VD2 minus VD1. So here M1 minus M2 is equal to V into D2 minus D1. So V is equal to how much we get? M1 minus M2 divided by D2 minus D1. So this is equation 3. This is nothing but equation 3. Now, what is the density of the object? Density of the object is mass upon volume. So here we successfully find out volume of the body. Now we find out mass. Now, equation 1 into D2 minus equation 2 into D1. 1 into D2. This is the equation 1. This equation should be multiplied with D2. Then what happens here? M1 D2 minus M1 D2 minus M1 D2 is equal to M1 D2 is equal to M0 D2 minus V into D1 D2. Right. Multiply equation 2 with D1. M2 D1 is equal to M0 D1 minus V into D1 D2. Now subtract this equation. So M1 D2 minus M2 D1 M1 D2 minus M2 D1 is equal to here M0 into D2 minus D1. M0 into D2 minus D1. Now we get M0 is equal to, what we get here? M0 is equal to M1 D2 minus M2 D1 divided by D2 minus D1. Now we want to find out density of the object. Density of the object is equal to original mass by volume. So here original mass is equal to how much? M1 D2 minus M2 D1 divided by D2 minus D1 whole divided by, what is the volume of the body here? M1 minus M2 divided by D2 minus D1. So what are cancelled terms here? Here the cancelled terms are D2 minus D1 cancel. So finally we get what? M1 D2 minus M2 D1 divided by M1 minus M2. This is the correct answer. Okay. M1 D2 minus M2 D1 by M1 minus M2. So this is the density of the object. Okay, now let us discuss about another problem. Here acceleration due to gravity same at height h from surface and at a depth h from surface. Then find the value of h. Find the value of h. So here, so this is the surface of the earth. So from this surface, this is a point at a depth h. The value of g is same as that of the value of g, which is at a height h from the surface of the earth. Right. So this is nothing but radius. Only whenever this point is attracted only within the radius of this r minus h. R minus h. Now here both are same. We consider both points. Here this is a one point and this is another point. So this point is at a distance r plus h from the center of the earth, and this point is at a distance at a radius r minus h from the center of the earth. Now we know that the value of g on the surface at a height h from the surface is equal to gm by r plus h whole square. Gm by r plus h whole square. This must be equal to the value of g at a depth h. That means this point is at a distance r minus h from the center of the earth. Gm by r cube into r minus h. R minus h. Here gm cancel. Now we write r cube is equal to r plus h whole square into r minus h. R minus h. Here r cube is equal to r square plus h square plus 2rh into r minus h. R minus h. So r cube is equal to r square into r, that is equal to r cube plus h square r plus 2r square into h, okay, minus r square h minus h cube minus 2r h square. Right. Here both sides r cube cancel, and here 2r square h. Here this is h square r. 2r square h minus r square h. H square r plus r square h. So here r square h minus r square h minus h cube minus 2r h square is equal to 0. Square is equal to 0. Right. So we write here 2r h square, 2r h square r. What we take common here? Bring these all terms to this side. That is equal to h cube plus 2r h square minus h square r minus r square h is equal to 0. H cube plus h square r minus r square h is equal to 0. Take h common. H square plus hr minus r square is equal to 0. Now take the roots of this quadratic equation. So h is equal to minus b minus r plus r minus square root of b square r square minus 4ac plus 4 r square divided by 2 into 1, 2. So here h is equal to minus r, we take a positive sign, plus square root of 5r square by 2. So here h is equal to minus r plus root 5r by 2. That is equal to take r common, r into root 5 minus 1 by 2. So this is the answer of this question. So what is our correct option here? Root 5 minus 1 into r by 2. This is our correct option. So now we are going to discuss another problem. Light is incident on a sphere of refractive index root 3 is placed in air as shown. Find the angle theta between emergent ray and reflected ray. Emergent ray and reflected ray. So this is a light ray. This light ray is incident on a sphere at an angle 60 degrees and it enters into the sphere. This is angle of refraction. Angle of refraction. Right. And this light ray strikes the boundary of a sphere, glass and air with an angle r dash and emerges out. This is emergent ray and this is the emerging angle. Now we want to find out the angle between reflected ray and emergent ray. Angle between reflected ray and emergent ray. How we can solve this problem? Let us discuss. So apply Snell's law at this point. N1 sin I is equal to N2 sin R. We don't know value of R. R. N1 means the refractive index of air. What is the refractive index of air here? Refractive index 1 into sin 60 is equal to N2 root 3 into sin R. So 1 into root 3 by 2 is equal to root 3 into sin R. Root 3 cancel. Sin R is equal to 1 by 2. R is equal to how much we get? 30 degrees. Here R value is 30 degrees. Right. See, this is the center of curvature and this is this side equal, their radius. This angle becomes 30. This angle R dash also 30. There is also 30. This is isosceles triangle 30. Now apply Snell's law at this boundary. Here N1 sin I is equal to N2 sin R. Okay. Now we want to find out what here? Angle of emergence. N1 that is equal to root 3 into sin 30 is equal to N2 that is equal to refractive index of air medium. The light ray travels from glass to air. So 1 into sin E. So root 3 into sin 30 1 by 2 that is equal to sin E. So here root 3 by 2 is equal to sin E. That means E equal to how much? 60 degrees. Equal to 60 degrees. Right. Now, if this angle becomes 30, this angle also becomes 30. This is also R dash from loss of reflection. Here the light ray is reflected. Now we use one principle here. R dash plus theta plus E is equal to how much? 180. R dash from figure, from triangle law, or these are the angle, the total angle on the straight line is 180 degrees. R dash plus theta plus E is equal to 180. So here R dash is equal to 30 plus theta value we don't know, plus angle of emergence is equal to 60 is equal to 180. Okay. Now theta is equal to 180 minus 90, that is equal to 90 degrees. So what is our option here? The angle between refracted ray and emergent ray. This is refracted ray and this is emergent ray. Emergent ray is 90 degrees. So this is the correct option. Now we are going to solve this problem. Charge capital Q is distributed on two concentric spheres of radius small r and capital R. If charge density of both spheres is same, the electric potential at the center will be. So these are the two concentric spheres, and the radius of the smaller sphere is smaller. The radius of the capital sphere is capital. So the charge distributed on the smaller sphere is Q1, and the charge distributed on the bigger sphere is Q2. Total charge is distributed capital Q, that is equal to Q1 plus Q2. Q1 plus Q2. This is equation 1. Now the given charge densities are equal. Charge densities are equal means here sigma 1 is equal to charge density of the inner sphere Q1 by 4 pi r square, and sigma 2 is equal to Q2 by 4 pi capital R square. They are equal. So sigma 1 is equal to sigma 2. Now Q1 by 4 pi r square is equal to Q2 by 4 pi capital R square. Okay. Now we get here Q1 by Q2 is equal to what we write here, small r square divided by capital R square. Small r square divided by capital R square. Right. Now we want to find out Q1 and Q2. Here what is the potential at the center due to inner sphere and due to outer sphere? So V is equal to 1 by KQ 1 by R, potential due to the inner sphere, and also potential due to the outer sphere, plus KQ2 by capital R. KQ2 by capital R. Now we want to find out what Q1 and Q2. Right. So here this is equation 2. So from 2 Q1 is equal to what we write here, Q2 into R square by capital R square. R square by capital R square. This is equation 3. So now substitute 3 in 1. 3 in 1. So Q is equal to Q2 into small r by capital R square plus Q2. Q is equal to Q2 into R square plus capital R square divided by R square. Now that implies Q2 is equal to what we write here, Q2 is equal to Q into capital R square divided by small r square plus capital R square. Small r square plus capital R square. So now similarly we find out another value of Q1. So here from 2 what we write here, Q2 is equal to Q1 into capital R square by small r square. Substitute this in 1. Right, capital Q is equal to Q1 plus Q1 into capital R square by small r square. So here capital Q is equal to, take Q1 common, 1 plus capital R square plus small r square. That is equal to Q1 into R square plus capital R square by R square. Now we write Q1 is equal to Q into R square by R square plus capital R square. Q into small r square by R square plus capital R square. Right. Now substitute Q1 and Q2 values in this equation. So here what we write here, V is equal to K. So Q1, K common, take K common, Q1 is equal to how much? Q R square by R square plus capital R square into small r plus, what is Q2 here? Q2, this is Q2. So Q capital R square by small r square plus capital R square into R. Okay. Now V is equal to, we write K into, take Q common outside, this R square cancel in R times. So what they common, take this R cancel in R times, KQ divided by small r square capital R square common. What we get here, small r plus capital R. So this is the potential at the center of the spheres. This is very lengthy problem. So do this problem quickly. So our option is V is equal to KQ by R square plus capital R square into small r plus capital R. Right.